Okay, welcome everyone once again to our class. And I'm happy we were able to, during the past weeks, been able to go through what Stellar is as a blockchain. We've been able to understand the full component of Stellar, starting from Stellar core itself, down to the node participants, down to how quorum slice work, what a quorum is, even down to the consensus mechanism of Stellar. And to end it last week, we had a test, and I'm so happy with the results I saw from the test, as it shows that participants have truly gained from the previous class. So when I started this class, some have not joined the class, and I said it will be a very practical class, but I will be sectioning it into two parts. And why I did this is because sometimes, even if there are recordings, we might not want to exactly go and watch the full recordings all over again. Rather, we would want to just immediately get what we want, either from a documentation, a slide, or whatever. So that's why I prepared this slide. So you can easily just go back to it, refer to it, and you are able to remember most of what is done. So we'll be starting with the introduction to Rust. Rust is actually a systems programming language. And in fact, I made this slide in a way whereby they are very, very short. What is Rust? Rust is a language empowering everyone to build reliable and efficient software. What exactly does this mean? We have been talking about Soroban smart contracts, and why are we talking about building efficient software? Well, there are different programming language out there, and different programming language have their own structures and their own benefits and their own implementations. Now for Rust, Rust is a very efficient programming language. And one thing Rust allows you to do is it allows you to, in fact, do so many things. It allows you to, build software ranging from OS, I can hear noise, okay, ranging from OS to even web application, because there are some frameworks that allow you to use Rust to build web applications. You can also use Rust to build back-end applications. You can use it to, in fact, build microservices, big structural, big infrastructures that a full company runs on. But then, why are we learning Rust when we are talking about Stellar? We are learning it because the Soroban smart contract was built with Rust. And whenever you are writing your Soroban smart contract, it's like you are writing Rust. So for you to write your Soroban smart contract, you have to understand Rust. And that's why we are learning Rust. And in fact, we'll be learning Rust up to a point whereby we all can confidently say, yes, I understand this language to a certain degree. So what are the features of Rust? One is ownership model. Rust has an ownership model in that there are different programming language when you define variables and then you reuse that variable somewhere else. It overwrites it. But the ownership model in Rust allows a variable to carry on the value it has, right from a function to another function. And also, this model allows it to drop a variable. It allows a variable to drop a value in certain points. And why are we having all of this dropping and carrying? This is due to efficiency. Now, this is what leads us to what another key feature of Rust is: garbage collector. Now, there are different programming languages that have different garbage collectors. What exactly does garbage collector mean? Now, whenever you are using memory in a programming language, you need to understand that there are different types of memory. Now we have the stack memory and the heap memory. Now, for every variable you declare in a programming language, it refers to what we call this memory. Now, different types of variables now refer to different types of memory. Now, in some programming languages, this memory management is not easily managed. Why? This is because whenever you are running a program, no matter what programming language it is, if you are running it on your machine, now your machine memory is where all these variable memories are located to. All of what I'm saying, I understand how abstract it can be, and that is fine. But why I'm talking about this is because at a particular point, when we start talking about memory management and seeing how Rust is able to manage your memory for you through one model, which is the ownership model, another model, mutability model, all of these, we are going to see how Rust handles it. But for now, we are only just going to talk about these terms. And then whenever you remember these terms, you then come back to this class and say, yes, this is the application. And that's why I'm talking about it. And it is very all right if you do not understand it right now. Modern syntax. Rust allows for modern syntax, even if it allows you to write the language in a very low programming, even if it has the capability of a low programming language, that's a low-level programming language, you still have the opportunity to do what? To write modern syntax. And some of this syntax is what we are going to see. Syntax is basically some key things you use to declare parameters or functions. All of these are syntaxes in Rust. So moving on. Benefit of Rust, the memory safety. It prevents null pointer dereferencing. If you are very familiar with JavaScript, you understand that JavaScript, one of the biggest problems it has, especially when you are running huge program, is the null value. Sometimes if you do not handle your null value yourself, one thing that happens is it might break your process. But Rust handles this perfectly. It handles it, I'm just going to say one way it handles it. It handles it using option enum. That is one way it handles this. This option enum, you are able to use a value or a none. And this is completely different from null. Let me come back to the class now. Since the class is going to be a practical class, I want to understand so that it can shaping how I discuss about this programming language. So I don't use references as to other programming language. Oh, I'm sharing my screen. Is others not seeing my screen?
I can see.
Oh, oh, oh. So I would like to ask, are there anyone on this call that have previous programming language experiences? And are there those that have not written code before on this call? I'd like to know.
I'm just starting to learn all this stuff, but I've never really written anything.
Great, great, great. What of Francis? Okay. What of Chibuezim? Are you there with us? Foxy, are you there with us?
Yes, I have knowledge. I have a
Okay.
programming background.
Okay. What programming language did you write before?
Solidity, JavaScript, and currently learning Rust.
Oh, great. Very great. Levi, I believe Levi has some level of programming languages. What of Titus? Titus, can you hear me?
Yeah, I can hear you.
Okay. Do you have previous knowledge on programming language?
Just basic knowledge, basically. Basic
Okay,
knowledge.
great. Okay, great. Ogaga, what about you? Do you have previous knowledge on programming language?
Yes, I do. I do have
What
Python,
language?
Python Solidity.
Okay,
I'm,
great.
I'm even looking at Rust, kind of, but it's okay.
Very well. Very
All
well.
right.
Excellent.
Thank you.
Excellent.
Yeah.
So we have a major um a majority having previous knowledge on programming language, and that's very good. That's very good. So coming back to our slide, Rust handles concurrency very well. So what is concurrency? Concurrency is the ability to run two different programs simultaneously. And now these two different programs running simultaneously can exchange data while running it simultaneously. Rust allows for these to work seamlessly. So whenever it is running this concurrency, it avoids data race with ownership. So Rust basically handles concurrency very well. And if you are a type of person that would be looking into working on distributed systems, that is, if you in fact want to become a core engineer, not just on the application layer as a blockchain core engineer, one of the things you might have to understand very well is concurrency, as you would use this to build distributed systems, as this is one important thing to understand to build distributed system. Another thing is performance. Compared to C and C++ with minimal runtime, Rust has the ability to create high performance. And this is, in fact, one of the very reasons why Rust is chosen as one of the top languages today, performance. Also, the system type. You have it as it expresses enums and pattern matching. All of these are things we are going to see as we proceed in learning the language. And to start with, I forgot to add that Rust is also a type-safe language, in that whenever you declare a variable in, for example, JavaScript, you do not have to name it that, okay, this variable is a string, it's a number, or is a character, a char, or you don't have to name any of that. But in Rust, every single variable you are naming, you are declaring, okay? Okay, I have some questions to ask about interacting with the Stellar blockchain from the user interface. Should one use through the Soroban smart contract or via the Horizon, or can it be done with both Soroban or Horizon incorporated together in the application? So at the end of this class, please let's give answers to that, as I would not want to distract this class with the answer. Is that clear? Thank you. So Rust is a very type-safe language. And now for the ecosystem of Rust, it has Cargo Package Manager and crates.io, where you can basically create a crate. You can build a crate, and that's your code. After running it, you can push the crate to crates.io and publish it here where other people can basically use it. Now, installing Rust. Obviously, most languages, you don't just start writing the code. You have to install the setup on your laptop. And that is, in fact, one of the reasons why I said I asked if everyone on the class have their laptop right with them. So for this installing of Rust, we would, in fact, go to the reference. We would in fact go to the reference. I would share this tab now. We would in fact go to the reference Rust book. So everyone with your laptop, please, we would be installing Rust now. Okay. I don't know why. The Rust book is not opening. Okay. So I'll drop this link here. So I would want everyone to install Rust using this command and to follow up as we do that. So you copy this to install.
I think that one's for like
The Mac
um,
OS and Linux, yes. So you
Yeah.
open your command line. I think I'll be showing my screen now. I've installed Rust before, but I would in fact be sharing my whole screen now to demonstrate this and then ask those who have already, yeah. So I'll be showing my screen now. And for this, so here is the command. I have installed Rust before. So open your command line and then you paste this in to install Rust. So since I have installed it before, I would not be running the command anymore. So I have sent the link, and for those, here's the command to install the language. So I would, as I made mention of, it would be a very practical class, and I would want to see, okay. So there are instructions to install it on Windows. So to install it on Windows, here is the instruction to install it on Windows. For me, I'm using Mac OS, and so to run it on Windows, here it is. So let me drop this link on the group. Yeah. Okay. So I would like to ask who are those that have been able to install theirs, since I would want everyone to follow along as to what we are doing. So have anyone been able to install the have anyone been able to install? Please signify if you've been able to install.
I've got mine.
Okay. What of Francis? Have you been able to install? I would want everyone to follow up as. So, Ogaga, have you been able to install the Rust command line.
I've installed it before. I've installed Rust before on my system.
Okay, great, great,
All right,
great.
thank you. Yeah.
What of Chibueze Francis? Have you been able to install it? One reason why I'm asking is I want everyone to follow along as we go through the program. So everything done in the class, you are easily able to follow along. And if you have a problem installing it, you can, in fact, share your screen so we solve the problem together. And so that's why. So what's up, Tobias? Have you been able to install it?
I'm actually on the street right now. I joined the class to kind of like follow along, but sadly I won't be able to do this until I arrive home. However, I intend to do it, and I will report back when I give it a try.
Okay, great, great, great. What of Purity? Do you have Rust installed on your laptop now?
Yeah, currently I'm studying it. I actually left the core because of some network issues. So I'm doing it now.
Okay,
After
great.
it's done.
Okay, great, great. Levi, I want to believe you have Rust installed before, right? Sorry, I could not hear Levi. Did anyone hear him?
Oh, I said I've installed it before now.
Okay, great, great. So I guess Excel and Coxie, have you been able to install it?
I already have it installed.
Okay, great. What of Excel?
Yes.
You have it installed already, right?
Yes, I've done it. I did it just now.
Okay, very well, very well. So since majority of the class now have it installed, we will then talk about the basic syntax. To declare a function in Rust, you use what we call fn to declare a function. To declare a variable, you use let to declare a variable. I'm sure those who are familiar with languages like JavaScript understand let, as let is familiar with JavaScript to declare a variable. But in Rust, you use let to declare a variable. Now, control flows are um, um, statements in Rust that that work based on certain conditions. So an if-else statement is a kind of condition in the language whereby if a certain condition is not met, the program inside the block of code in the program of the if or else statement would not run until that condition is met. And that happens to loops too. Loop is basically a kind of program whereby certain lines of code are being run over and over and over and over until a break is added to it or the break condition is added to it, is met. Match is basically an alternative to if-else statement. It's also a type of control flow where you match certain conditions. So if certain conditions are not met, certain block of codes are not run. So until certain block of code are met and conditions are met, then certain block of codes are then run. So this is example of what a Rust program looks like. And in fact, when you create your first Rust program, this is exactly what you would see. Function main, print line, hello world. So this print line is basically the syntax you use to print whatever you want to display on your command line. And so this is exactly what it looks like. Variables. Variables, as I've made mention, are declared to store a value. Now, look at this line of code. Let x equals 5. X is the variable, 5 is the value. So you are storing 5 in this variable x. And to declare that it is a variable, you declare it by declaring this syntax let. So let x equals 5 means you are storing 5, which is the value in the variable x. Now, as I made mention that Rust have certain property, and one of those property is mutability. So now, if you want to mutate a particular variable, now notice that this variable is stored in a memory. And if you remember in the beginning of that class, I made mention of two types of memory. I made mention of the stack and the heap memory. Now, in this case, 5 is stored in the stack memory because the stack memory is a type of memory whereby the size of the program, the size of the variable is determined before the storage. So in this case, 5 is the size of the variable and it is a uint. And this uint is defined because it has a size, and the size can easily be allocated on the stack memory. And so 5 here is immutable. So now coming back to mutability, let's mute y equals 10. If you put on the next line y equals 15, it allows you to mutate it because of the keyword mute. The keyword mute allows you to mutate an already declared variable to another, to contain a new value. And one might ask, why immutability? It encourages safe and predictable code. So in a situation whereby you mistakenly use the same variable name you have used initially, if you do not have minds of mutating it, if you use that same variable name, if this particular feature of mutability is not added to the Rust programming language, if you mutate it when you do not want to mutate it, it could cause problems in your code. And that is why some certain code bases are so big. For example, some JavaScript code bases that are so big, sometimes you start debugging errors, and you don't know where your error is coming from until when you have wasted so much time debugging it. But Rust programming language allows you to easily predict your error because it has it shows your error at compile time. So that easily allows you to predict your error. Another feature of Rust when talking about variable is what we call shadowing. Shadowing is a situation whereby you declare a variable, you do not mutate it, but then you redeclare that variable, and then when redeclaring that variable, you now do what? You mutate it. So this kind of transformation is a transformation whereby variables are mutated without the mute keyword. So in that case, it is called shadowing. In that situation, you have shadowed the previous value of the variable. So in this case, if you are to print out x in this case, can someone tell me what x would be now? Can someone tell me what x would be now?
Is it 6?
Thank you very much. X is 6 now, and that is because it has been shadowed. Data types. We have scalar types, that's single variable, single value. Okay. Okay. Questions? Question. Valentine. Okay.
Yeah, I was just so like if Rust is immutable, right? So like, why isn't like Python is mutable? Like if you declare something in Python, what does it mean that that's mutable and then Rust isn't mutable? Thank you.
Okay. Great question. Now, as I made mention of at the beginning, different programming languages have different features. And now, in this case, to answer your question, I'm going to write the code to answer your question. But before writing the code, I'll give the answer to you the best I can before writing the code. So whenever, going back to this, in a language like Python or JavaScript, when you declare when you declare a variable, for example, you declare x is equal to 5. Now, you can go to the next line and say x equals 6. In this case, in some languages like Python or JavaScript, since x has been declared initially, it can immediately change to 6. But then, due to safety, and because obviously developers are humans and they can make mistakes, due to safety, whenever you are equating a variable that has been declaring before to a new value, you then need to ensure you add the mute keyword. So in that case, you are like, I want to mutate this variable before I change it. So that means in a later time, a particular function, or in fact, my program itself, can mutate this variable whenever it is run on that line of code. So that is allowing for safety. Now, in a language like JavaScript, you do not have the opportunity to do such a thing as having inbuilt ability. In JavaScript, if you write let x equals 5, or you can go to line 20 and just say x is equal to 6, and immediately it mutates. You understand? But for safety, this is not how it's done in Rust, and this is how it's done in Rust. So yeah. And as I made mention of, during the course of practicalizing all of this, we would see, I would in fact write out the code, and you would see how at compile time, it is able to, in fact, show error that, oh, excuse me, do you want to mutate it? Did you add the mutate keyword? And I will, in fact, ask you personally, Valentine, a question when that happens. So I think Coxie also have a question. But before that, have I answered your question to a particular point, Valentine?
Yeah, I get it. So like with Python, you can basically change it in the same
Yeah.
code in whatever. But with Rust, it will tell you like it will always stay the same.
Yes.
And it will tell you if you've like messed up somewhere. But I need to see an example, I think.
Definitely, you would see an example. You'd see an example. Coxie, you have a question?
Yeah, I'm sorry. From this last slide, you showed us that um, going back to the other one.
This one?
Yes. You said let x go into 5, then let x go to x plus 5. But you talked about the mutation that when you want to change like a variable, you have to use the mute. Well, in here, it's more of like yeah, it's not really changeable. You're actually doing something to that variable. Why are you not using mute there? Like, why are you just using let x? Why not mute?
Excellent question. I actually expected someone to ask that question. So now, in this situation, we are saying that we are changing the value of x without actually using the mute keyword. What does that mean? And what's the difference between the compiler telling us, okay, change x before using the mute keyword? For this, in fact, at this particular point, I think it is time for us to practicalize it in code to give answer to this question. But that before then, let me quickly say something. In this case, you are redeclaring x. And now you are redeclaring x and saying that x now, I want x to no longer be equal to 5, but I want it to be 5 plus 1. Because initially, on this previous one, x was 5. So I want x to be equal to 5 plus 1. But in this particular case, you are saying that let x equals 5. Then on the next line, you say x is equal to x plus 1. Did you notice that you did not add the let keyword there? The let keyword means you are redeclaring. And when you are redeclaring, that in that case, it shadows the previous one. But for this one, you are not redeclaring. If you notice this example of let's mute y equals 10. On the next line, it is y equals 15. You are not redeclaring that let y equals 15. Does that make sense?
Yeah.
Thank you very much. I am trying to get to the end of the slide before we move into practical. But notwithstanding, we are going to go through the slide. Or, in fact, let me stop sharing the screen. And I think it's nice to, in fact, practicalize what we are talking about now. So I would share my whole screen instead. And in this case, yeah, I hope everyone can see my screen. In this case, I would yeah. So for this, I would be creating new I don't know if my screen is bright enough. Can you see my screen,
Yeah,
or is it too tiny? I just want to be clear.
it's okay.
Okay, great. So for this, plus one, no, plus one. So for this class one, to create a new program in Rust, to create it, you do what we call cargo new, and for this, I would call it lesson one. Lesson one. So a new binary application has been created, as you can see, called lesson one. So if I do this, I can go into the directory lesson one. So inside lesson one, we see cargo.toml and src. And here it is here. Lesson one. Source, you have the source. Then you have main.rs, .gitignore. .gitignore is where all the files you want to ignore that you do not want to push to GitHub is added. .cargo.toml is where you add all your packages and your dependencies. So while working on the Soroban smart contract, when we start working on it, we'll be able to see different dependencies that we might be using on the Soroban smart contract. This is where you add it. Just like in JavaScript, you will do npm add or npm install certain packages. This in Rust, you have the ability to add a package by just typing out the package name and the package version here, and it automatically grabs the package from cargo.io, or you can basically add it by doing cargo add the name of the package. Now for main, this is main, and as I made mention of, in main.rs, this is where your program is run for Rust. So for this, to run your program in Rust, you have to run cargo run. Now, if you can see my screen well, cargo run returned hello world. So print ln is used to print out whatever you want to print out to the terminal, just like I mentioned of. But I'm going to remove this. And in this case, I'm going to practicalize what I have discussed earlier, starting from Valentine. Just to be clear that we are still together in the class. Valentine, your hand is still up. Do you have a question or something?
Oh no, I just didn't put it down.
Okay. So starting from Valentine, you made mention that declaring a variable x equals 5. Oh, sorry. You end every value, every line of code on Rust with a semicolon. Some languages, you don't have to add it in some languages, but some other languages, it's important you add it to semicolon. I can hear like a distracting noise. Okay. So, yeah. Now, in this case, and this would also answer your question, Cogsy. In this case, if we said x is equal to 6, do you think the code will run? Let's try it. Cargo run. Did you notice something? It said cannot assign twice to immutable variable. Cannot assign twice to immutable variable. So there's error in the code. But can you fix this error for me, Valentine, to answer your question? Remember I said I will ask you, how can we fix
Yeah.
this error? What should
Yeah,
we do?
one second, it's the fan that's making that noise. So you can put the bit of code that says that makes x a mutable variable, right? So later on you can change it, or if something basically it can be changed. So you just declare it as a mutable variable first.
Thank you. Thank you. That's the answer to the question. You declare it by adding this mute keyword. So by adding the mute keyword, you are able to declare x as a mutable value. So if you run this code again, cargo run, this time it is not showing error, and the code is compiling perfectly. So in this case, just to print this thing, a variable on the terminal, the value of x is, this is how you print it, and you add x at the back. And then, so if you run cargo run, right here, we can see the value of x is 6. And so there is no error. Now, coming back to your question, Cogsy, in a case whereby we do not have mutability, we did not make it mutable. If we redeclare the variables again, this time, should we have an error? Cogsy, do you think we would have an error with this line of code before I run it?
Let's try it and see now.
I want to hear from you based on my previous answer to you. Do you think we
Um,
would have an error?
no, I don't think we will, because we are declaring it again.
Exactly. And in this case, it is called shadowing. Once we
Okay.
run the code, x is now 6, as you can see here. The value of x is 6. And in this case, x here has shadowed the value here. So in shadowing, you can basically still use the previous value to shadow. So I was reading 5 here, and then I called 5 here, and then reshadowed the value, the variable x here. So if I run this code, it should tell me x is 11, basically. So that's the difference between shadowing and mutability. So I guess that answers your questions perfectly, right? Thank you. So I'll start sharing the slide back so we can continue from the slide. So earlier we talked about data types. Now there are different types of data. Example of data that I've made mention of is this particular variable, x. X becomes a data. The 5 here, I mean, is the data. And this data, we are storing it, this data, 5, we are storing it inside x. We are storing it in the variable x. In this case, this is a singular data. It is a single value type of data, a scalar type, whereby it is not compounded. Now, there are other types of data, other types of compounded types of data. And in this case, we have different types of compounded one like arrays, structures, enums, tuples. All of these are compound types of data. And we are going to see example of all of what I have just made mention of. And we are going to see what it looks like. Key concepts, strong types with type inference. That means that each type, you have to declare each type while declaring it. Now, if you go back to the code, in fact, let me stop. Let me just keep sharing all of my screen so it is easy to just go back to the slide and the code. Notice what I said. Everyone is strongly typed with type inference. So going back to this code now, notice that I did not declare anything in front of 5, but it knows and understands that 5 is a uint value. How does it know this? I'm going to close this program and open it directly from here, so you can see what I'm trying to say well. So lesson 1, open it here. So yes. So notice that there is a kind of syntax in front of this X that says I32, integer 32. All of the variables declared in Rust programming is actually typed. This means that there are two options. If you do not allocate the type of the variable, it is going to assume what type it is based on the variable you've given it. So in this case, we gave it 5. And now in this case, it assumes that it is an int 32. And int 32 is a variable type. And we are going to see all of that. But the point is that every variable declared in Rust have a variable type attached to it. And in this case, if I double click it, you notice that I32 has been added to it. But in this case, I'm going to come back. I'm going to do something later on after I've explained the other types of variables. Scalar types, other types. For the scalar types, we have integers. We have int 8, uint 8, int 16, uint 16, int 32, uint 32, int 64, uint 64, int 128, uint 128. One might ask, what is the difference between int and uint? Int is integers, while uint is unsigned integers. What does this mean? This means that whenever you are using a variable as an integer, each of that variable you are using must always be either addition or subtraction. So that means that variable can be -1, -2, -3, -4, -5. It can also be 1, 2, 3 to the maximum of the integer. But for unsigned integer, that is U16, U8, U32, U64, U128. Did I notice a hands up? Okay. For all of these are unsigned integers. And these unsigned integers only accept positive values. So for the unsigned integers, they have to be 1 from 0 to the maximum value of the uint, the maximum value of the unsigned integer. So this is the difference between int and uint. One might now ask, what then is the meaning of this 8, 16, 32 at the back? Now, if you remember something I made mention of, I kept talking about storage, storage, and memory. Now, variable you declare, for example, this X is a variable that you've declared in this line of code. It is storing this particular 5, the value 5 inside X. But in this case, the value 5 is 5. That's the size of 5 is 5, basically. So what then is the maximum variable size this I32 can take? The maximum size it can take is 2 raised to power 32 minus 1. That is the size it can take, the maximum size it can take. If you put that in the calculator, it's just all about calculating the bytes and the bits. So you can basically calculate these bits in the sense that you calculate 2 raised to power 256, then your result minus 1. That is how to calculate. So the maximum value is that particular value I've just made mention of. If the variable, that is the value of X, the value you are putting inside the variable X exceeds that 2 raised to power 32 minus 1, then it's what we call overflowing. So overflowing occurs. In this case, you understand that you might need to use a different variable type. That is, you might need to construct your own variable type to contain that variable you are using. So whenever you know that, okay, the variable that you'll be declaring, for example, for this X, if the variable you are declaring 5 would not at any point of your program exceed 2, let's say you want to use I8, would not at any point exceed 2 raised to power 8 minus 1, then it is safe to use it, as in that case, you have managed the memory that you are storing this value 5 in. So whatever the variable X is mutated to, that variable, the value it is passing in to this variable X must not exceed 2 raised to power 8 minus 1. If that happens, what we call overflowing occurs, and then there's error in your code. All of these things are beautiful ways whereby your data is secured. Now, if you're a type of developer whereby you have used JavaScript well, you will understand that debugging is not a good thing. And all of these things that has been incorporated in Rust, this mutability, this variable type, and the size, it all allows you to write an efficient code. So imagine writing X is X and declaring that, okay, X is an int8 variable type. Then at the end of the day, you know that the particular memory space you are using for X is what? 2 raised to power 8 minus 1. So you don't use what you don't need. And in that case, it allows your code to run efficiently. And that is exactly the reason why Rust programming language allows for different sizes. And now if you think about other languages like Solidity, Solidity is another typed language, if you are familiar with it. Solidity allows you to write uint 8, uint 16, uint 32, and on and on and on like that, up to uint 256. Allowing you to do this allows you to specify a particular memory allocation for the variable you are, for the value you are storing in the variable. So when you are using a particular gas fee on the EVM in that particular case, you don't spend so much, and then you are able to easily optimize your gas. Okay. I think, okay, questions. Does int include negative numbers? Very correct. Int includes both negative and positive numbers. Then, can you share the slides again? Definitely, I would share the slide for you to go through it. Then is int 32 for 0 to, or 0. Yes, it's from -21474. It's from the negative to the positive. Yes, that's very correct. So floating point. Now, whenever you are writing your code, another scalar type is the floating point. The floating point allows for decimal place. So float is basically used to write a variable whereby the value you are storing in that variable is in decimal. So for this particular case, notice something I'm about to do in this case. All of these things that I am doing, I am going to eventually still do them all over again. Okay, I'm going to remove this. I'm going to remove this. Notice that these things identify that this is a I32 value. It gave it the maximum one. Imagine I add 0.0 to this. What happens to this? It becomes F64. F64 is what? Is a floating point value. So now, notice that it has given an error. Why is it giving an error? This is because you cannot just add or do an operation between a floating point, a floating number, that is a floating value, and a uint or an integer. You need to ensure that the value you are using for the operation, all of the values are either floating or integers. So in this case, you can either say 6.0. If you add 6.0 to this code, the whole error is solved. Or if you don't add 6.0, you can say 6 as F64. Doing this solve the problem. And so if you run this code and run cargo run, what you have is this. So now let's say 6. Let me use this as 6.4. So if you run this, what you have is 11.4. So for that, it's a decimal point. Another type of variable type is Boolean. Boolean is true or false. And another one is char. Char is basically a Unicode, and we are going to see how you use this char. The difference between char and string slice. What is even a string slice? What is a string? All of this is what we are going to see in our next class, as this is how we come to the end of our class for today. We'll be stopping our class right here. So, are there any questions up to this point? I would not want us to bore us so much with so much information for the first day. So are there any questions right now? Does anybody have any question based on what I've been taught right now? If there are no questions, this is how we come to the end of our class for today. And I will be stopping the recording here. And then we look forward to tomorrow's class where we continue from where we stopped.